Hi all, this is Professor Disha Shukla and today's my topic is large scale path loss. Our subject that we are conducting or going through is wireless communication. So what do you mean by large scale path loss? See, whenever a signal is traveling in a particular region, it may happen that it can lose its own path. That is, it may happen that after some distance or after some time the energy of the signal will decrease, so that is called a path loss. And how does it actually occur is our topic for today. See, co-channel interference or CCI exists when two or more devices are operating on the same frequency level. So the co-channel interference is not actually an interference but more a sort of a congestion. So it hinders the performance as we have already seen, and the 802.11 protocol is designed to address this situation and utilize the channel in the most effective way. So the introduction of a radio wave propagation. The mobile radio channel places a fundamental limitation on the performance of the wireless communication system. Radio channels are extremely random and do not offer easy analysis. So modeling the radio channel is important for determining the coverage area of a transmitter, for determining the transmitter's power requirement and determining the battery lifetime. So finding the modulation and coding scheme to improve the channel quality is requires that we determine the maximum channel capacity. So actually whenever you are modeling a particular radio channel, it is important to determine all these parameters, that is the coverage area, the transmitter's power requirement, the battery lifetime, the modulation and coding scheme, and maximum channel capacity. The mechanism behind the electromagnetic wave propagation are diverse, but it can generally be attributed to reflection, diffraction, and scattering. So mainly electromagnetic wave propagation depends on three mechanisms, that is reflection, diffraction, and scattering. The propagation models have traditionally focused on predicting the average received signal strength at a given distance from the transmitter, as well as the variability of the signal strength in the close spatial proximity to a particular location. That is, the propagation models that are traditionally built, they focus on predicting the average received signal strength, that is the average of the received signal. At a receiver side, whatever signal you receive, its strength will be averaged and at a given distance from the transmitter. So the propagation models that predict the same signal strength for an arbitrary transmitter receiver separations are useful in estimating the radio coverage of a transmitter and are called the large scale propagation models. So whichever propagation models that can be helpful for predicting the mean signal strength of an arbitrary transmitter or receiver that are separated by some distance, that is usually useful for estimating the radio coverage of the transmitter and are generally called the large scale propagation models. So on the other hand, when a propagation model that characterizes the rapid fluctuation of the received signal over very short travel distance or short time durations are called the small scale or fading model. That is, in contrasting to the large scale propagation model, the small scale or the fading models are the ones in which the propagation models characterizes the rapid fluctuation of a received signal strength. That is, when a signal is traveling for even a short distance, there will be a rapid fluctuation in the received signal strength. So at the VLF, LF, that is very low frequency and the low frequency and medium frequency bands, the radio waves will follow the ground, that is AM radios. It will be broadcasting using the MF bands. Now at the HF bands, that is the ground waves, they tend to be absorbed by the earth. The waves that reach the ionosphere are refracted and sent back to the earth. So this is how the high frequency bands operate. That is, the high frequency band, in the high frequency band, the ground waves will be tending to be absorbed by the earth, and the waves that reach the ionosphere, they will be refracted and that will be sent back to the earth. That we have already seen in the three propagation waves, that is the ground wave propagation, the sky wave propagation, and the line of sight. So for the VHF, that is the very high frequency, the directional antennas are used that is, the waves follow more directed path, that is, they transmit in a particular direction only. And line of sight communication, reflected waves interfere with the original signal. Hence what happens is, in the VHF, the line of sight signals will be interfering with the original signals. So the three propagation mechanism will be seeing over here. The physical mechanism that governs the radio propagation are complex and diverse, but generally are attributed to the three factors, that is reflection, diffraction and scattering. So first of all, what is reflection? So it occurs when a wave impinges upon an obstruction that is much larger in a size as compared to the wavelength of the signal. That is, whenever a particular signal is traveling in a particular plane, and if it strikes to a particular place where from where the signal will be refracted back, so that is reflected back, that is called the reflection. That is reflection from the earth and the buildings. Whenever a particular signal is traveling and when it obstructs to a building, it will be reflected in some other direction. These reflections may interfere with the original signal constructively or destructively. That is, the original signals that we have, they will be either it will be constructive or it can be destructive, both. What do you mean by diffraction? Now, diffraction occurs when the radio path between the sender and the receiver is obstructed by an impenetrable body and by a surface with sharp irregularities, that is the edges. It explains how the radio signals can travel the urban and the rural environment without a line of sight path. So what do you mean by diffraction? In a diffraction, when the radio path between the sender and the receiver is obstructed by an impenetrable body, that is, the signals or the waves cannot penetrate through that particular body, they cannot pass through that particular body, are called the impenetrable bodies. And when when such kind of obstructions occurs, and by the surface with the sharp irregularities, so when such kind of obstruction occurs and the signal will be changing their direction or they will be losing their strength, that is called, the process is called diffraction. The third process here is scattering. So it occurs when the radio channel contains the objects whose size are on the order of the wavelength or less of the propagating wave, and also when the number of obstacles are quite larger. They are produced by the small objects, rough surfaces and other irregularities on the channel. It follows same principle with the diffraction. It causes the transmitter energy to be radiated in many directions. Lampposts and street signs may cause the scattering. So these are the possibilities through which the scattering occurs. So this is an example wherein it is shown the R represents the reflection, the D represents the diffraction and the S represents the scattering. So say for example, this is a vehicle, it is traveling, and when its ray is transmitting, and here when it collides with a particular building, it will be reflected in some another direction. This is something where the light will be the wave will be colliding and it will be changing here. So this is called scattering, that is, more than one part of this particular signals will be occurring. And the third one is the diffraction, wherein it occurs because of the edges of this particular building. So these are the three particular parameters or the three reasons through which the radio propagation mechanism occurs, that is the reflection, the diffraction and the scattering. The three radio propagation mechanisms, as the mobile moves through a coverage area, these three mechanisms have an impact on the instantaneous received signal strength. And so if a mobile does have a clear line of sight path to the base station, then the diffraction and the scattering will not dominate the propagation. So if a mobile is at a street level without LOS, that is line of sight, then the diffraction and the scattering will probably dominate the propagation. So as the mobile moves over a small distance, the instantaneous received signal will fluctuate rapidly, giving a rise to the small scale fading. So what do you mean by small scale fading? So whenever a mobile moves over a small distance, the instantaneous received signal will fluctuate rapidly and it will give rise to the small scale fading. The reason is that the signal is the sum of many contributors coming from different directions, and since the phase of these signals are random, the sum it will behave like a noise. In a small scale fading, the received signal power may change as much as 3 or 4 order of magnitude, that is 30 decibels to 40 decibels, when the receiver is only moved by a fraction of the wavelength. So in a small scaling, the reason is that the signal is the sum of many contributors that is coming from the different direction. That is, there will be lot of transmitters in different direction, and they will be transmitting the signal, and since the phase of these signals are random, the sum will behave like a noise. The addition of all those noise will behave like a the addition of all those signals will behave like a noise. That is the relay fading. It is called the relay fading. Now in small scale fading, the received signal power will be changing as much as 30 decibels to 40 decibels when a receiver is only moved by a fraction of wavelength, and as the mobile moves away from the transmitter over the large distance, the local average received signal will gradually decrease, and this is called the large scale path loss. That is, as the mobile will be moving away from the transmitter over the large distance, the local average received signal, the locally received signals average, it will be gradually decreasing. So typically the local average received signal is computed by averaging the signal measurements over a measurement track of 51 to 401. The mobile models that will be predicting the mean signal strength, that is the mean of the signal strength for any arbitrary received transmitter separation distance, are called the large scale propagation models, and they are useful for estimating the coverage area of the transmitter. So this is how the whole three the propagation model mechanism, or the three radio propagation mechanism works. So they are basically, there are three types, and the path loss or the fading we saw are two. There are two types of them, that is small scale fading and the large scale fading. So in a small scale fading, it occurs generally because of the addition of the or the whenever or when the received signals will be added to each other, and it will be creating something like a noise. So that is called a small scale fading. And the large scale fading is something wherein the distance between the transmitter and the receiver is very large, and the loss that occurs due to it is called the large scale fading. So there are three types, or there are three basic mechanisms through which the propagation occurs, that is the reflection, the diffraction, and the scattering. Reflection is something wherein a particular signal will strike to an object, and due to that it will be reflected in some other direction. The diffraction is something wherein it strikes to a particular, again it will be striking to a particular object, but due to that it will be changing its direction. That is called the diffraction. And the last one is called the scattering, wherein a particular signal will be, it will be divided into more than one parts. So as an output of the scattering, whenever it will be striking to a particular object, it will be divided into more than one parts. So this is all about the propagation model mechanism. If you have any questions, you can ask me. Until then, keep learning.